Hello, class. Today we're beginning our discussion on Chapter 4, Material Requirements Planning, or MRP, which is one of the most important tools that modern production and supply chain management uses. At its core, MRP ensures that the right components are available in the right quantities at the right time to support a master production schedule. This chapter introduces how MRP works, how it connects demand for finished goods to the parts and materials needed, and how it manages both dependent and independent demand. We'll also dive into the bill of materials, which serves as a product's blueprint, and learn how MRP uses this structure to calculate timing and requirements. Along the way, we'll look at how MRP adapts to real world challenges like supplier delays, demand shifts, inventory shortages. But by the end of this discussion, you'll see why MRP is essential not just for manufacturers, but also for service providers who need precise planning to avoid waste and meet customer expectations. Again, think of MRP as the nervous system of production. It coordinates every part to ensure that the whole system performs smoothly and everyone is working together. So let's get ready and get through this. Thank you. I appreciate all of y'all's attendance. Again, by the end of this lecture, we'll explain what MEP is and why it matters. We'll distinguish independent from dependent demand, interpret key bill of material structures and reports, and we'll also talk step by step through exploding, offsetting, and netting requirements. And you'll see how MRP connects to the master bill layout. This is a little repetitious, but I want to make sure when we look at the learning objectives, we understand what they are. And we're going to see how MRP connects to MPS, which is Master Production Schedule, CRP, Capacity Requirements Planning, PAC, Production Activity Control, and Purchasing. I always feel like purchasing should have a little acronym also, but I guess that's perch maybe, but I made that up. Don't count that as a question on a quiz. But purchasing is one of the big important parts that helps the MRP system continue to flow. So we're going to go over a few of those examples. One example that how that works together is the Dell computers. Many Dell computers are built to order. And in fact, that model that they use and sell, it relies on accurate MRP to time phase parts into production without bloating the inventory. So there's a lot of things that happen behind the scenes. We're going to start learning about that with these learning objectives for this chapter. So next slide. So we go over with when we are trying to set up MRP, you have to figure out what is the nature of demand. What types of demand are there? Independent, dependent, vertical dependencies, and then some is like a hybrid of both. For instance, independent demand in the top left is for finished goods and must be forecast unless firm orders exist. You have to forecast for independent demand. And dependent demand is derived from parent requirements and usually is calculated. You need something to build something else, and it's not forecasted. It's always dependent on something, a trigger for them. A single item be cannot be built without it being dependent on something else. So it's dependent in assembly, and independent is usually a spare, right? It can be spares or one-offs. Vertical dependencies tie components to parents. And horizontal dependencies mean a delay in one component can ripple across all of its siblings. So if you have one piece of a component that's used in several assemblies, it could delay production across the board in that kind of operation. Uh, One example is, when you purchase auto tires, uh, they're dependent in an assembly. If you're you're getting them for a car, well, they're dependent on being put on the car, depending on what the car demands. But independent usually is what you would see on aftermarket purchases. Say you buy a car and it has these kind of tires and you want some super different ones. You want mud tires to go mudding if you have a truck, or you could probably put them on a car if you want to. But that's an aftermarket purchase, and you'll kind of see that where the production models for those kind of differ a little bit, because when you're going to build 500 cars a month, and they all have this specific tire type, then it's easier to say, okay, we know how many tires we're going to need. We can make purchasing requirements, we can have delivery requirements, and we can plan appropriately for them. But if you're more diverse, we don't wait to put the tire on until it gets to the dealership. Then there's like, okay, there's a lot of independent aftermarket purchases and planning that needs to be taken care of. But typically a tire might be the best example, because they're built in large volumes. They're not built one piece. So that's the nature of demand. Now the objectives of MRP, well, its first objective is what, how much, and when to order to satisfy the MPS. Remember that MPS. It's time phasing releases with realistic lead times. It needs those. And the second is to keep priorities current as customer orders, scrap, and other supply delays occur. Your customer orders may vary, uh, and you got to keep the priorities scheduled. You need to say, well, we had a large amount of the tires that came in got scrapped. Oh wow, we've got to be able to recover from that. Now, do we plan for a certain amount of scrap? If yes, you did a great job. If no, then you're going to be hustling and trying to find solution. And there are other types of supplier days that could impact that. And what we look is we want to keep those priorities straight. That means that we're going to rely on a forecast and real time feedback to make decisions. Planners adjust by either expediting, moving orders up, or delaying orders, pushing them back. So in a majority of manufacturing environments, uh, due dates are a little bit uh, adjustable, but not a lot. When you move them up and back, it's just to make sure your delivery to keep that customer happy is your top priority. One example is how Boeing reprioritizes MRP on a daily basis to manage supplier slips that may otherwise halt assembly. Had this example with the airline manufacturing, well, not airline, aircraft, uh, on the F-35 production line. What we had a few single source suppliers, uh, so we had to manage our MRP daily to see if is everything coming in on time. Fortunately, we had a robust enough manufacturing schedule where we had enough in the line that we had everything delivered just in time. That's a concept we've discussed. We would usually have 2 weeks out before it had to start production, and everything was coming together before that aircraft was put on the line. And so if it was at 2 weeks, if everything wasn't there, we readjusted the daily schedule. So when we got to that 2 week period, we had something else already in place, either moved up, or sometimes we would put in rework that happened at the beginning of the line to keep adjusting and keep us on schedule. And that's a very efficient MRP system. We had that with Lockheed Martin on the F-35 production line, and to see it happen, and it was an army of supply chain and logistics folks and planners and purchasing. So we also asked, what does it link to the other MPC functions? Well, how do they all link together? The master schedule is the engine. right? And the MRP translates the end item plans into components. What needs to be built when. The capacity planning it verifies that machines and labor can meet these needs. So you've got to know what we're capable of doing on a daily basis, and if there are delays popping in and out of the production schedule. This is a manufacturing environment, but it stretches across all industries. It's just you may need to tweak it. It's the same method for solving these problems in capacity. Because if you can't meet the needs, the plans or capacity have to change. You have to say, we're going to continue to build, we're going to build more, or we're going to have to build less to keep the product line flowing. So pack and purchasing convert planned orders into shop and purchase orders. If you ever look at how that is, you get the orders so they're released and ready to go out to the floor. If anyone of you have worked in a manufacturing facility, you understand. Okay, where are planned orders happening? Do they go to shop orders so everything be pulled and ready and deliver? Do we have to make purchases to make sure we're on time and on target? And they manage the execution. How do you do that? Well, one way that you need MRP software. So what is MRP software? Where it's evolved a lot over the last 20 or 30 years. Uh, when I started, it was a spreadsheet. And for a while, it was paper being handed off and checked throughout the day. So before computing, firms compensated for slow human math with large inventories and early ordering. I mean, it was not uncommon to have warehouses full of material enough to take care of a year's worth of orders or more, which you paid big prices. You had to get a big warehouse, or you had to pay somebody extra to keep it. But back in those times, like it was a long time ago, uh, you usually had your own big warehouse, and that means you need an army of logistics and supply chain people in that warehouse to keep everything organized, everything in the right place, make sure nothing was lost. If you had discrepancies to scrap, uh, and you had to have people to manage it. But modern software, it phases thousands of parts. It keeps track of all the inventory and any issues that are exceptions that could trigger you that an action is needed. When you do regular counts, it'll pull from the inventory. So things some inventory systems are set up to have regular counts going throughout the facility at a regular basis. So one of those is ABC allocation, uh, and what that does, it designates how often inventory should be touched, or counted. High movers, you probably want to touch high movers a little more frequently. The slow movers also, depending on their priority and cost, how hard is it to replace them if something happens, and so some different approaches of that. We'll get into that later. One approach I had is when I walked into uh, at Kirtland Air Force Base at Sandia Labs, we were saying, "Oh wow, well they would shut down the whole facility twice a year to do a month inventory each time." So we were essentially dedicating 2 weeks a year to do wall-to-wall inventories, as was a requirement of that contract. So when I came in, I was like, why are we doing this? And we were also at that time implementing some new technology, digital transactions and barcodes. They didn't have barcodes before. Everything had to be visually verified, part number, serial number, quantity. But when I came in, we started implementing barcode technology, and we finished an audit. And I said, okay, the next time you come back, this will take less than 2 weeks. And talking to our government, auditors, we had to get permission to make sure we barcoded everything, but we did that, and it took us that complete 6 months before their next visit to get everything barcoded and on a schedule. And with that, they had shut down for the regular 4 week time frame. We took advantage of that software. We were walking around scanning, and immediately, because of the way we had it set up, there was Wi-Fi was not that great back then. So we walked back and plugged in all the scanners, and it instantly downloaded everything and told us discrepancies, right? And if we scanned something that wasn't supposed to be there, it told us. So when we focused on, we said instead of everybody being all over the center, we said let's go one building at a time, and we said, hey, uh, we expect we can finish all 15 buildings that we needed to touch, you know, 10 days or less. So when we started this process, we did one building at a time, one building, bam. And we said, oh, okay, we found some discrepancies. We found some found material that wasn't supposed to be in that building. It was in the wrong office or the wrong location. And immediately we were able to reconcile it. We didn't have to go figure out where it was supposed to be by a spreadsheet or a form. And so that was like immediate action, and it was like, okay, everybody came and downloaded. So at the end of the day, we handed back a report and said, here's our discrepancies. And we would give it to two people and say, go straighten these out. And usually that would take a day or two, depending on how many there were. But almost everything solved itself immediately because you found one part in the wrong room. Oh, it was supposed to be in this other room. Let's make sure we do a transfer and get it in the right place in the system. First, we wanted to find out why it was in the wrong room. And we said, oh, okay, we need to make the determination it needs to be in that other room because there was a space or in that other location in that slot. So those were some advantages with the MRP software evolving, and like I says, manual MRP, it's workable, but as you get a big enough system, it's quite a task. You need an army of people. Uh, Computers, they made the speed and accuracy I spoke of. Instantly, we knew what was where and what wasn't there, and there was common logic across the systems. That all the databases we had were linked together, and it was a big server back then. Now it's on the cloud, so it makes a big difference. So one good example is SAP and Oracle. They have these systems in place that are great. They make everything simple, MES, and they synchronize a lot of plants, you know, they in different manufacturing areas into one system, so you can see it. You can see it across, a campus. You can see it across a city, a state, a country, and even across continents, depending on the size of your business. This was extraordinarily helpful with Lockheed Martin when we were working on some repair facilities for the C-130 aircraft. We could see where parts were all over the world, and because we eventually that system we put in place at Sandia Labs, we put in place all over the company, and that was a great time to be traveling and visiting places and islands, and uh, it was a good part to be part of that implementation. And but the good thing was we could come home, and when we were looking for something, and we were like, we don't need it. We need to get that part built. We'd say, well, there's one on the Kwajalein Atoll. Well, let's give them a call and let's see if we can fly it in tomorrow. And that happened a couple of times. It wasn't like frequent, but you could see something. If you need it, you can order it and have it delivered to the location you're taking the part from. So that's a topic on MRP software evolution. So then the next thing we say, what are some key inputs uh, that go into MRP, right? And you say, well, it's like we said, it's only as good as the data that goes in, right? If you good data, good input, you can probably plan on good output. The NPS declares what end items are due and when inventory records track availability. It's like when it's supposed to be there, and you can see when it's received, and you say, "Whoa, it's ready right now." And Because I used to hear all the time from our purchasing team and our buyers, "Oh, it'll be ready for production tomorrow. You'll have it in production tomorrow. You'll have it in assembly tomorrow." And the language they were speaking meant it's due tomorrow. And I spent many days on tomorrow, waiting on tomorrow. But when we started to make a smarter data being fed to the system, I can say, "Oh, there's tomorrow, and there's a tracking number. I know it's really due tomorrow." And if it didn't show up, we knew who to call. We knew how to track it. And that's what happens. And when it comes in the door, the quality approve it. Are all the checks in place? We have uh, all of our, is it in full compliance with what we ordered? Do we have any issues? And we'd say, okay, now it's ready for manufacturing or assembly. And that also helps, like, hey, the quicker you get it in the door, the quicker you can pay that bill. The quicker you can get that receipt completed. And we make your suppliers happier. If you're on the supplier side, shipping it to us, you're going to be happier because you're like, hey, I provide you all the information. It got received in the door. You show it as received, no discrepancies, pay that bill. And then you'd usually, whatever the terms were of payment, you have to work with that. Some companies have a 90 days. You want to do business, it's going to take us 90 days from day to pay. Some has 45 days. Some have some tighter guarantees. It's depending on the negotiated contract. And then you go down through the bill of materials. That's another thing that needs to be. You guys to list every component and usage, where it's used. That's really important because I've seen where we've had build plans put in place and the BOM is missing several items. So when it gets out to the manufacturing floor, the technicians who are doing the build or say, "Hey, I'm missing washers, I'm missing screws. Hey, I don't have a door." Well, it's not on the BOM. I would hear that a lot. Our engineer would say, "Well, it's not on the BOM, so they don't need it." And I'd be like, "Well, go back to the drawing board." Uh, so that's one thing that's very important. And when it's a key input that you cannot be successful if it's not good data. Bad data in any of these areas, inventory, NPS, planning, and bill of materials, uh, it means you're going to get a bad product. You're not going to be able to deliver on time. You're going to be behind schedule, and probably have a lot of other issues. An iPhone schedule drives the needs for screens, cameras, batteries, and any balance that's incorrect in those areas or misidentified could just halt production. I don't know if that's whatever delays iPhone rollouts, but I've seen power plants that we built with Eaton at a point when I was working with them as a consulting role that we stopped. We just shut down. Everybody had to go build widgets. I used to always say widgets whenever we started to build these. Basically, we would take engineers, welders, uh, electricians, and fabricators and have them go uh, connect clamps and build clamps all day just to keep them busy. That never made people happy. It never made me popular when we had to do that transition. And Me being popular was not something I was really too concerned about. But you want everybody to be happy. You want if you're paying an electrical engineer to come in and perform a task, you want him doing electrical engineering tasks. You don't want him building clamps, which is essentially what it sounds like: a nut, a bolt, and a clamp. Doing that where, okay, for us to make the money back for production, we had to build thousands of those a day to cover the costs of keeping everyone working. And so that was kind of a bad thing when that was the only thing we could switch over to. And that's another example of, hey, we're going to have to switch MRP. We're going to have to change our production schedule. So The key inputs is good data makes everybody happy. So be careful on how you collect data and how you use it. So here's an example of some bill of material basics. Kind of covered a bit of it, but it counts for every item needed to build a product or a parent. You got to identify all the unique parts, the numbers, any changes, any alternates. Sometimes during a build, there's an adjustment made after the product has been released. You say, am I using the most current bill of materials? Do I have all the products identified on a current bill of materials? So rev revision is important. If there's ever any revs and you received it on the floor, one product, one manufacturing process we had to put in place before he got automated was when they started a manufacturing step, they'd have to look at the bill of materials and check our database to make sure it was the most recent. And in fact, every handoff at every step, we had to check that. And it created a few unique problems when that first step was not done. Eventually, we automated that, so when we scanned the production order, it would verify that that's the most current bill of materials, it's the most current rev, and they could feel confident that I need to just check for these parts. Uh, so those are some interesting tie-ins when you think about building these products. And anytime you do a change, it's either a rev change or a part number change. Bill of materials specify what goes into the product, and routing specify how it's built. Sometimes the routing would change a bill of material on the bill of material, and you'd be like, oh well, how is that? How is that happening? Well, instead of building one part, you may change the order that it's built in, and that means we have to adjust how it's rolled out on the assembly line. Giving these examples so y'all kind of think about how complex this really is and how detailed it is. And it's kind of exciting. If you like the challenge of I want to juggle numbers, or I want to make sure everything fits in the place that it's supposed to, that's where this part of the uh, logistics and supply chain gets a little exciting. And planning bills, they can represent, an average easy product or a whole family. Like I said, one Dell laptop with a lot of different variations, and that always goes back to, are our bombs right? Are we forecasting our plan builds right? Do we have our so if our bombs are right, we know what we need to buy. It goes all the way back to purchasing. It makes them happy whenever there's a change. If it drastically changes and we can't use alternates, so and like we call it multi-level planning bombs. It's an interesting concept. It's like we built with Schlumberger some products where one part of the build took 14 weeks, and the start took 2 days. So we had to build for everything to flow in sequence and be ready. We had to start. At level two, before we start at level one. And usually we try to coordinate who's building what so we can pull people off and it all come together. It looks like a perfect orchestra. So, you know, think about that. Look at things around your house and say, well, how would a bomb work for that? And look at, for instance, a table in your living room or dining room. You need legs, frame, hardware, a top, whether it's painted, what color it's painted, and if it's what kind of wood. So there's a lot of things that could be the same design for the table, different models, and that means the bomb changes a little bit. So that's just kind of around the house example. And when you're doing all this, you got to say, what are the structures for a bill of material? What is that? A product tree view, a parent-child links. It's top and bottom. What needs to be built first and second, like I kind of mentioned previously. Single level versus multi-level builds. A single level means you could probably put it on an assembly line and just go straight down the line, building as you go. Multi-levels will be you got to integrate parts in to an assembly line. Uh, um, and where product is used, for pegging and traceability, so you can always keep everything working. Uh, So there's quite a few things on the structures and reports. Uh, One example would be a brake caliper, that's in several bike models. So what you'd have to say is, oh, we've got two or three different, 10 different bike models coming out. Let's peg to that build to so which sales orders drive the near-term needs. So if we're building like on demand, or we have expected surges in inventory, or offering big sales on specific models, then you may have to say, well, let's peg this product for these brake calipers to these Model 10s, and we're gonna push back the Model 4s for a little while because we're trying to push out the Model 10s on a big sale or as during a rollout, for example. Uh, we've all probably been in a store where we see the latest model. They've got tons of them, but one that's same year, different model, just a little off. You're like, man, there's only one or two, and but I really like that, so you may have to be delayed and say, well, I might have to wait to buy that, or ask when are the next orders coming in, and plan your purchasing differently. Can you go through this or say, what is the MRP overview? What is this? You know, uh, what is our engine? How is this happening? Right? Well, uh, the engine explodes the end item that are needed at the lower level. When you explode a bill of material, you see everything, right? It's you see the usage, you see the timing, the lead times, and the plan on how it's going to happen. Coming out of inventory, and you have to project. Well, in 6 months, we've got these planned builds. We're going to see a big drop on our inventory items. We need to plan to replenish. What's the lead time on the products that we're going to see a drop below min max orders? Well, okay, we may need to start placing that order earlier, especially if you expect an extended period where you're going to have more product being used. Uh, so, the result is just a calendar of planned receipts and planned orders for every item. But when you build an effective uh, inventory system in your MRP, you're going to be able to see that you build it min maxes appropriately, and you plan out your min maxes appropriately based on uh, how long it takes to get product in. As long as you're consistent, order every time we hit that min. So before that volume is consumed, we'll already have new product in the door. That sometimes is hard to do, but if you do your MRP reviews on a periodic basis, uh, I suggest uh, no more uh, than 90 days. If you let 90 days go by and you haven't reviewed your MRP and looked at how production is planned for the next 90 days or quarter, you probably will find yourself rushing at some point, or staying late and pulling your hair out, and trying to figure out how did this happen. But planning helps make sure that you're successful. And so when you're trying to say, hey, how many do we have on hand? Well, you have the gross minus on hand and how much is coming in. You always know what's sitting in stock. It's not rocket science. It's usually pretty straightforward. And you say when you create the time phase purchasing and release, you say, oh, okay, how do we do that? Well, you know how long it takes to place the order, to receive the order, to get the order available for inventory. Really, like a key thing is available, not just received in the door. When can our production teams or the end user put their hands on it? Those are some very, very crucial things that take into effect. And a lot of companies are good at it, not great at it. A few are great at it, and you rarely see shortages or delays in production. One example is, if you do 100 laptops a week, six trigger early needs for screens, keyboards, and batteries in weeks. And you say, well, 100, that's not too bad. But the lead time may be 3 to 5 weeks. So you're like, wow, I need 100 in a week, and we're going to be six short because we didn't plan for really that volume. and it's going to take 3 to 5 weeks. Well, if it was me, I'd say, well, anytime we get down, if we know what our average sales are in a 30, 60, 90-day period, or maybe it's during Christmas, the end of the year, you may ramp up a bit, or the end of the fiscal quarter, because companies like to spend all the money they have. And they say, well, look, they'll say, oh, Emma had that product over there. We can go over there and uh, we're going to buy 100 from her. Typically they may only buy five. Well, Emma's going to be happy to sell all 100, but when she does that, she's going to be in a rush to say, how can I keep building? But if she knows that usually happens on a regular basis, you're going to say, well, let me ramp up in October, November, December. So, hey, it's the end of the year for us. We want to make sure we're spending wisely. And because we usually see everything sell out, we usually see our shelves pretty bare at the end of the year. And that's a good thing, right? Uh, Unless you have big rushes the first year. But then it's like, okay, we're going to be building like crazy at the end of the year. Let's make sure we're stocking like crazy and receiving like crazy. Get as much product in the door so once that rush slows down, you're going to get some returns. Then you can usually turn around those and uh, get those back out in a resale. Offer them at discounted prices and make sure that they don't sit in your inventory and push them back out the first year while you're rebuilding your inventory that may have been depleted. So all that is timing. You got to have time to to know how long everything takes to get in the door. So here's the interesting what's exploding. Well, exploding, it multiplies the parent requirements by the usage to compute the needs, right? To figure out the needs. Uh, it is like, well, what do we mean by that? It means if you have you blow open the bill of materials, you look at it, you say, what are our needs? You know, what are lead times associated with those, so we can make a determination. Are we going to need to order now or pay an expedite fee, or do we have the appropriate inventory on hand to adjust? So every time you receive something in the door, you're looking at, oh well, that means it wasn't ordered yesterday. Hopefully not. Hopefully it was planned enough so you can have an accurate financial plan and make sure you're being successful. Offsetting shifts those needs backwards by the lead time. So materials arrive before assembly. Like I said, that's the best way. You have to know these times. So if you say it's a 6 week lead time, a 4 week build, what we quoted a customer, well, okay, then we need to always make sure we have 4 weeks plus two minimum in inventory. Uh, because if you're like made to order, you're like, oh, our lead time customer is 4 weeks. It takes us 4 weeks to get that here for you. Okay, well I'll order it now. Boom. But if you've got already enough product out the door, or you're at capacity, you're gonna have to say every time I get to the 6 week mark on the products to build that model, I need to have the order going. Or you may say let's pad it with another week. You may say 7 weeks. So worst case scenario, you should have, if planning is done correctly, forecasting is done appropriately, you may have 3 weeks of inventory on hand. But that's why it's all important to you synchronize everything. You have to know what levels need the time to build them, when they're being built, and the always important thing, just in time. When is material going to be delivered? That's where you may have a team, purchasing buyers, and an expediting team, people that are supposed to watch everything to make sure it's not slipping, to keep that open line of communication. So, so that's exploding and offsetting. And then we say, what are our gross requirements? What are our net requirements? You know, when gross is a simple definition, right? I think We all know this. It's total need from the parents. It's total need from the parent product, right? It's not your mother and father. And the net subtracts the on hand and the scheduled receipts, so you always know what you have available, and and it prevents excess inventory. Uh, Netting ensures only the shortfalls ordered, which keeps inventory lean and service high. The projected available balances evolve period by period. They change, right, as receipts and issues occur. So you have to, keep an eye on that and have a trigger in place. Say, time to order. Time to order. Oh wow, we've got a surplus. Maybe the next order won't be as many, or you just wait if you're comfortable, if you have enough time to say let it diminish down to the appropriate level. And without netting, firms they typically always overbuy, and we tie up money unnecessarily. So you're like, wow, I've got, like we walked in and said, hey, we've got 2 years of inventory here, enough to build 2 years worth of products, uh, and so we kind of can hold off on buying if it depending on the lead time. Like I think I gave the example with Schlumberger on a different lecture was we had a 2 year build time, so we had to eat the cost of getting material in, ordering the material, paying for the material 2 years before we had to deliver, and it was literally almost a solid 2 years of on the shop floor build time for some of our tools. It was about 18 months, which you're like, oh wow, we had a 6 month window. Well, 6 months goes by pretty quick and you start missing delivery dates. Those are that's the concept of gross and net. You want to use that as an example. You need 50. You have 20 on hand, so our net requirement is 30. Okay, and is that the end of life? Do we have 50 coming around behind that? Okay, so if we see 30 in the next 30 days and 50 more 20 days after that, well, okay, may need to adjust. And is it better for us to get all 80? Because sometimes if you have products sitting less than 30 days, it's negligible, the cost of inventory, uh, depending on how expensive it is. Sometimes high dollar, you don't want to spend a lot of money and have it sit on the shelf a day that you don't need it, or a few days, because that's money. That's money spent that you're not recuperating. So that's why it's really fast acting and fast moving warehouses are very popular. High velocity movement is a good thing, but that takes a lot of planning. MRP is your best friend at that time. What happens during MRP when you get all these things figured out? You start the planner does what? He'll release the orders. And say a planner may run his planning schedule regularly and say what can we build. If uh, if it tells him everything he can build is on his schedule to when it's needed to be built, hey, everything's uh, everything's wonderful. It's paradise. Quite frequently, uh, that doesn't happen. But when it does happen, the planner converts the plans to a make or buy orders. Sometimes it's depending on demand. It's like we can buy this pre-assembly, just buy these parts, bring them in. We just do the minor assembly and get it out. Sometimes it's we need to make it from scratch. We need to get all the components and build it here. So the planners are in charge of that, and you have to keep an eye on that because when planner authorize it, it goes a purchase order or a shop order, a make order, and it goes into the schedule. So we say, okay, now it's on the schedule. How do we track it? Is it fit in our capacity? Are the materials reserved? And typically, best practice is you do not release an order if everything's not there. I've been in industries where they're gambling on, oh, it's going to be here in 2 days, so we can start this part, and when the rest gets here, we can finish, and there won't be any delays. Well, more often than not, I've seen where they start the build, and then it goes and sits in a corner for a week, and we have to juggle again and say, what can we keep everyone building? Everybody's gonna go work on clamps, or we got another product in line. And if you have another product ready to build and you're not building it, then you probably made a mistake by starting to build something that was partially received and over something that was not totally there and ready. I've we got into practice with our procurement team and our sales team. If we had to make adjustments like that, we would say we're building this now. Tell the customer if they'll take it a week early. Contact them. Can they take it a week early? Will they take it a day early? Will they take it a month early? Because we would see sometimes problems with certain products, and we'd have to say, we're going to have a gap in our production. So let's see what we can adjust. And that was something we covered earlier, moving orders in and out. And that involves everyone. You can't work in a silo in manufacturing. That's why MRP is a good system, part of the ERP idea, where everyone can see everything, and you start reaching across the aisle to everybody and say, "Hey, Mr. Customer Service, can you make sure that we can deliver this?" So those are just some examples, and of course, one role of planners. Depending on how large a complex company is, you may have that. It's a purchasing person's responsibility to track the open orders until they're in the door, and they have to make sure everything's ready. Uh, Sometimes it's the handoffs are not clean, the communication is not good, so no one tells the manufacturing manager that product's not going to be here. And then no one tells the planner, so he can't tell the manufacturing manager. So that's why there has to be good communication and cooperation across all parties. And the next one is MRP record and time buckets. The MRP record is a time-driven ledger of demand and plans, right? These buckets are usually weeks, and modern systems, they can be daily, right? Or they could be hourly, depending on the organization. I've seen examples of Amazon where they literally are hourly, right? And the horizon has to be long enough to cover the total lead time. So when you're planning these out, what is the total lead time? Hmm. Total me, it's like a landed cost. It includes everything, all the levels, everything that has to come in, and if anything's pushing back or causing delays, that is your horizon, right? One example is a washer motor shows that it's in week 4. That's when it's planned to receipt, but the release is in week 2. So you've got a two you got a 2 week gap right there, right? Uh, so it's okay. I may have 2 weeks to where I can adjust, right? But a lot of times, that 2 weeks evaporates very quickly. So always keep in mind you want to see the horizon. It covers all the time. So you say, I know I've got 4 weeks. It's going to be here in 2 weeks. It's going to be released. Great, great, great. I'm going to have 2 weeks to build. Well, is your build time included in that? So, it's just a few more things that when you look at the time buckets uh, and how they're set up. And our good friend CRP, Capacity Requirements Planning. Different organizations, this falls on responsibility of different people. It should fall a lot under planning and logistics. In some organization, it falls under a manufacturing manager, which or supervisor. Uh, and so what they're supposed to do, it's supposed to ensure that MRP that what MRP intends to build can be built with the resources, which include tools, people, and materials. So when it's planned, the capacity requirements plan has to make sure that it's achievable. If not, you're going to be adding our favorite word in manufacturing, overtime. Everybody loves overtime, unless you live overtime. Well, we hire subcontract people to help, you know, smooth out the bubble. Can we shift loads across teams to where the bottlenecks occur? Or one thing we don't like to do, reschedule, right? Sometimes look at it as a weakness that we're going to have to reschedule delivery. Uh, we've seen it. I've seen both ways where the customer gets very upset on a reschedule if it's a delay, and I've seen other scenarios where we say, well, our capacity is not going to let us do that. We communicate, but we can shift it and send you more of this other product while we're getting this done. And sometimes they get happy because they'll take a different model and a different volume than they intended, and especially if you throw in a discount, they're usually pretty happy. But it's not the best practice to not have your CRP in order. You know, so because you don't want to be adding overtime if you can avoid it. You don't want to live on overtime because that's usually an indicator that you're staffed wrong, you're planned wrong, that some mistakes are made because you're not efficient. You may be effective, but you're not very efficient, and that always costs the company. Bottom line, costs you money. It costs you stress on your employees and unnecessary hours. The goal should be to always plan 40, work 40. And if you got a long stretch of time where can I bring in subcontract people to perform some of the more menial tasks, so I can take these qualified manufacturing assembly engineers and put them on other roles, so we can still meet the product demand and take the ones that I can train someone to quickly and have them doing that job. That's usually I love subcontract for that. And shifting loads, alternating shifts, so there's more product being made in a day with the same amount of people, but they're kind of shifted, throughout the day. A lot of ways to adjust your capacity requirements. But make sure you check it before you release anything, because that prevents the chaos that you have where somebody's not going to be able to perform. They're not going to be able to show up for that overtime, that Saturday, that Sunday, that 12-hour shift, and you just keep falling further behind. Intel balances their wafer starts against the tool capacity, for their chip forecast. Like, for instance, hey, only so many can go through this uh, go through this tool on a certain day. I forgot the name of that device. We worked with it when I was a long time ago at the plant in Albuquerque, New Mexico. It, but there was only so much you could do a day, and I knew the agreement with us was uh, if that broke down, we were responsible for maintaining it, and we started paying them $4 million after 2 hours. Because that was the volume, and they had it running 24 hours a day. So if we got it fixed in 2 hours or less, no charge. But if we couldn't get it back and running in 2 hours, it was a $4 million. And then after then we got grace for 4 hours. Then it was $2 million. So it was heavy after that. It was we could get into some big costs. We never saw that happen. We had it happen once, but we worked out where we didn't pay. It was like, hey, get discount. We discount your service for the next 5 years. Hey, you got a 5-year contract with us now for free, and which was important for us because we still kept selling upgrades. But anyway, that's a different subject. The next thing is low level coding and netting. Well, what is that? It's assign each part to the lowest BOM level, right? you count for everything. Yeah, you aggregate the gross needs before netting, and you process top to bottom to avoid counting. Imagine that. And you plan each item exactly once per period. Depending on what your periods are, how often that occurs, it could mean a lot of things. Because we don't want to be warehousing, we don't want to be storing things. So those are important for us. So you have the bomb blown out as much as you can. And when you have multiple bombs and scrap, well, what do you do with that? What do you do when several products share a component? And MRP needs to sum all these needs into one schedule. So your suppliers see one unified signal. I mean, it's one order, right? It's not a bunch of orders broken out over several products. It's like, oh no, they sometimes they're supplying that one product. They don't care how many different models it goes into. They want to know how many do you need. That's what I mean by one unified signal. So that's where it's consolidate demand across multiple parents, and then inflating the planned releases for expected crap. Scrap. I may have been a Freudian slip right there. But scrap, uh, because scrap needs to be, you need to know what your scrap is expected on a product, right? I've seen when we had an expected 7% scrap rate on a certain type of material. And I was like, okay, good. So when we planned purchasing, we planned buys, we planned builds, we built that in. And whenever we saw, uh, an outlier where it went above that, we immediately investigated because we were planning for a certain percentage of scrap. And if we started seeing 10%, 10%, 10%, and multiple days, we would have to go back and adjust and say, is our forecast adjusting for this for what we're going to need over the next few weeks? So we don't get to a point where that extra 3% on the day eventually consumes all the material on hand before new material comes in. We've seen that happen a few times where the outliers are higher than planned or expected. It wasn't communicated back to the supply chain team that we're having this happen in manufacturing and that we're consuming more. And they had been in the habit of, for a certain product, oh, we only buy that once a quarter. So when we got down to the midpoint, they were like, we're not at the reorder time. And I was like, and I had to go have a very jolly discussion about we have a reorder point, not time, and we straightened that out so we could get the product there because we had to shut down a production line because for something as simple as a little 5 cent wire, and we had to shut it down for a 5 cent wire on a $38,000 product that we built 100 of them a day. So we were like, that was not cost effective. So we had to change the model to move away from buying times because they had their measurements built on a schedule of how much money they spent in a specific 30-day period, and they just stuck with it. They didn't adjust it. But we revised it. We worked as partners. We solved that problem. Uh, so that was because of the scrap situation. And planning bills, they usually you can get an average mix. But if you start hedging too much for an average, you're going to start having problems. It's going to create excess, and no one likes that, right? So you overhedge, you're going to have excess inventory, and depending on cost, like I said earlier, a small cost, not requiring a lot of space, you may be able to adjust that for a period of time or live with it, and may be acceptable. But if it's a big piece, high dollar, you don't want a bunch of them sitting around because it's kind of like a red flag. You see money sitting on the floor, and and that's not good when you pay attention to the MRP process, billing, and all the other tasks at hand. So that's how multiple BIMs can benefit you, and make sure you're safe if they're done properly. And scrap always has to be taken in consideration and planned. And so, okay, well, let's. What is a planner? We talked about planners. Planners are real important in MRP. I think planning is mentioned quite a few times in this chapter. What is your role? If you are the planner, if you're the production planner, you're the materials planner, you're the capacity planner, production planner is what they call them sometimes. Launch. You have to launch. That means uh, you release the work. You give it. You make sure it happens. Uh, which you could be pushing as the expediter. You could be holding it back, saying let's get a delay, or you say that's no longer needed. We can use another product for that. We were in that role one time. We were end of lifing. We were at a product that was going end of life, and we had some excess in inventory. We had enough to build, quite a few, and it was going into life because we were going to put out the next gen safety valve. And we said, well, let's wait a minute. So we said, let's go back on these ones that we sold, these next gens that we sold. Let's go talk to the customers who may be interested in a discount for taking this one we're about to end of life. As long as we negotiated that because we didn't want the inventory. We didn't want it all sitting in our warehouse, which we knew we weren't going to build anymore after a certain point in time. So we talked with a few customers out there, and we said, take these, and if there's any need for replacement or repair, you'll get the next newer model. And they were jumping on it. They enjoyed it because it was less expensive. They knew if anything went wrong with it, they were going to get the newer model at no cost, right? And it was a safe bet for us because our product we knew it was reliable, we knew it was great, we knew its failure rate was very low, and so we said, oh, we can make these last few very well, and it also gave us a little extra time to ramp up for the customers who were not willing to take the older model. Some companies are, I need the best and the brightest, even though they both perform the same function. So that's one thing we've done in the past. And of course, planner coordinates. He makes sure everybody is on the same page, the same schedule. It's like a master production scheduler or planner. And so as we're going through this, you may say, if we're looking at some big increases from customer service, their customer sales are like, oh, we've got a lot going on here, but we don't have very much the next quarter. So you lose what we know we're going to build, or we've planned out at the beginning of the year, or maybe part of a 1, 2, 3, or 5 year plan. You may be able to slide it in to fill the gaps and make sure everyone keeps working. And the biggest thing you do as a planner when you use the plan is you're always checking for data errors. Uh, data tells the story. Good data tells a good story. Uh, Good data can tell a bad story. So you always got to look to make sure that it's correct, and the right story you're going to have to tell. Where you're going to have to adjust if you have to go back and launch, coordinate, or use anything back in that cycle. So aerospace planners, uh, they always expedite. When a supplier ships because it threatens the aircraft delivery, and a lot of, for instance, Lockheed Martin, we had a specific time frame on how much we had to deliver, when it had to be delivered, and if we missed it, we had to get rebates sometimes. A lot of times it was if it was avoidable, and when we went back to our contract partner, and they said, well, that you should have been able to avoid that. Well, a lot of times it means they were telling us to give them a credit. But quite frequently, we had a good plan in place, a good process in place. Things that caused our plans to slip would be outside of our control. A single source supplier who had a major fire or accident, well, that means you're not going to get anything. So, pretty straightforward, not complicated. And then we have the MRP services. Service operations, is a fun place. It can adopt MRP thinking by defining the end items, the components, the timing. Uh, for instance, a cafeteria's menu is MPS, right? The recipes are the BOMs. The supplier and prep times are the lead times, right? Oh, okay. So, you're getting it in, you're prepping it. Those are lead times. Proper time phasing reduces spoilage. That means getting product in and into the freezer or, refrigerated storage at the right time so nothing spoils and you can meet the lunch rush, lunch demand. Those are just kind of some examples using this the MRP logic, the ingredients, the procurement for freshness and cost, and you meet the peak demand without waste. If you're kind of planning that it's going to happen, it's easier to say we're going to reduce the waste as much as possible. You know, a hospital cafeteria, if you ever go there, you're always seeing dairy and produce deliveries. They're not. They will run out from time to time. You'll be in there. There's nothing there, but that's planned, so there's no waste because it's not really a high volume like a Luby's cafeteria. But from time to time, certain products will be there and be consumed, and they want to make sure they don't sit long and they have to throw it out because they're not there as a profit margin for a cafeteria. So how do we manage exceptions and keep everything stable? Uh, that's a that's something it's not a difficult task. Yeah, the supplier, the shop, and management feedback. You need that. You need that. You need to know what they want and what they think is being done right and not done right. You prioritize their expectations. So what you want to avoid is constantly them coming back and saying when, or what's next. So if you have the feedback, it goes both ways, and you set the priority, then your partners know exactly what's going to happen and when it's going to happen. And you got bottom up replanning from the lowest level, right? What is bottom up? That means you're the planner. What are you looking at when you say bottom up? You want to go figure out when it's going out the door, right? And that way it will dictate uh, how long your timeline is for planning, really. And say, because I walked into a situation where they told me that takes 6 days to build, and I said, "Oh, really? Great. We can handle that." But when I did a walkthrough, I went to the bottom. I went to the last point on the assembly line and walked forward to the first point. And when I learned, is no, that takes 6 weeks. Where'd they get the 6 days from? Well, they were looking at a chart that showed human touch time, and I was like, oh yeah, it's a lot. Not much touch time, but all the queue times, the wait times, the overnight, heat times that we had to do for certain parts of the manufacturing process took 6 weeks. One heat test, took an entire week on its own. So it was a big problem that no one had ever looked at, which I don't know why. But when I stepped in, I said, "Well, wait a minute. Let's give this information back because when that manufacturing facility, those folks have been working. When I walked in the door, they'd been working 12-hour shifts, 10, 12-hour shifts consistently 7 days a week." And I said, "Well, oh, wait a minute. Why are we doing this?" And when I found out the expectation was that it takes 6 days, so I said, "Oh no." I met with the right people. I went back to the operations team and said, why has no one ever said it takes more than 6 days? Well, that's what the chart says. No one ever questioned the data. So again, the bottom line, data accuracy is your best stabilizer. You got good data, you're gonna be able to see data. If you have no data, you don't know where the problem is. You have data. If you know your data, you're gonna know the problem and you know where to fix it. Part of it was all communication. Everything kind of is a constant circle. You need supplier, shop, and management feedback, communication, prioritize what's got to happen, when it's got to happen. You take the question away from the customer, and where they don't have to worry, they know. Imagine that. And bottom up replanning. Go to where the last step is and move it forward so you can have your timelines in place, and that gives you the data that you need to plan product, materials, deliveries, builds, and ultimately a happy customer. So that's how you manage the expectations and make sure you have some stability. Those are a good 4 points to constantly churn through all the time. So that's pretty much it. It's here it is. You're looking at it as out of your window at a manufacturing center, a distribution center, and saying, how can I get stuff out the door? It's a Galveston College distribution center. It's a beautiful place in my imagination. So keep in mind, this one's fully automated. It's got a few people, but most of it's you got the R2 units moving product. So as we close out chapter 4, remember that materials requirement planning is more than just a scheduling tool. It's a system that brings order and precision to the complexity. The complex problems of production. It makes it in order. It makes it easy to see. It makes it easier to problem solve. And by linking the master production schedule to the bills of material, the inventory records, along with capacity planning, MRP ensures the materials flow. Again, I say this several times. I say this is my mantra. The right place to meet customer demand. We want the customer to be happy. We saw how it manages dependent and independent demand. It adapts to constant changes, very constant. It provides planners with clear priorities to keep production on track. The effectiveness of MRP is it depends on accurate data, and a disciplined use of the systems that you have at your disposal. Some of it is very human, and some of it is fully digitized. So without these tools to get the accurate data, even the best software can produce poor results. So you're the one who's going to make sure that let's get the good data in and we've got the good results out. And as we transition to chapter 5, we'll explore how inventory management connects directly to MRP. The balance of materials on hand versus what is planned to arrive drives many systems to make the decisions and the calculations, give you the alerts, or give you the good news, bad news, or the decision news. And together, these topics, together, all as everything starts flowing, we'll build our understanding of how logistics, planning, and execution intersect in modern supply chains. So that ultimately mastering MRP helps organizations meet the customer needs efficiently while minimizing waste and costs across the board. So keep that in mind. This is an interesting chapter because it brushes over the topics that we need to say, how do I make the decisions? How do I make the problems go away? And or sometimes it's how do I revisit? How do I identify where the problems are? And the data will tell you. And going to where the problem is, Gemba, go to the source. You'll see things start happening a little differently, and be more successful. Never be afraid to go to where the problem is. If you're going to where the problem is, it's always the same person. We may need to have a hiring decision change. But if it's because one person's always discovering the problems, that's pretty good too. You may have someone who really has insights. And if that's you, you'll be more valuable to organization. You can imagine if you're the person who can walk in and you always see the one-off, and you always can find a solution. Keep that in mind. That's the best thing to be as a planner. Always checking data and customizing it to the needs. So that's it for chapter 4. That's our closing summary. Look out the window, take a deep breath, and let's move forward.